Hello, everyone. Thanks for joining our very first Swarm workshop. We're going to have so many different things for you to go ahead and learn right before the hackathon season kicks off. Today, we're kicking off with something very simple, however, something that you can take it out and say, okay, which direction do I want to go and learn more about Swarm? So Swarm 101 will be handled by our Aaron. He is someone that works with the products and engineering teams, and you will learn everything about decentralized storage. So from the architecture and peer-to-peer topology, how the storage models works and the neighborhoods, the proximity ordering, and we're also going to touch economics, how the postage batches work at Swarm Foundation, what are the storage incentives, what are some of the spam protection. So if you wanted to figure out the way how you can decentralize your storage, what else is there to be offered by Swarm Foundation, this workshop is for you. This is just the first of many of the series that we're going to have, and stick around till the very end. I'm going to give a little bit of a brief introduction to other workshops that are happening in the upcoming months as well. Swarm Foundation is excited to welcome you, and we always are looking for feedback to interact with you. If you have an idea, something to build, and you need builder support, join our Discord. We're going to share a QR code here as well. I highly recommend for the ones that are following the workshop today to also join specifically this link through this QR code, because we also going to have Aaron, who's leading the workshop, to make sure that he answers any of your specific questions. So no matter where you're watching this from, Twitter or YouTube, I highly recommend to also jump into our Discord channel, because that's where we're going to make sure that we also stick around after the workshop and give you any added information, clarification, solve the bugs together. And that's also a hub for us to give feedback, to say, hey, I'm looking for this feature. So I highly recommend for you guys to go ahead and join our Discord channel. Now, we also wanted to have a little announcement that for you folks that prefer to learn about Swarm in person, we are also heading to Cannes at the end of this week, and we're going to host a small event as well. More details on that on our Twitter will be following as well. So if you want to learn or ask anything about Swarm Foundation, how can you contribute to decentralized storage, maybe decentralized streaming services? If you have ever been curious and have more questions and you prefer in person, you can come and join me and meet me next week in Cannes. All right, without any further ado, again, make sure you join the Discord, and I think we're all set to start the workshop. Aaron, do you mind joining the stage with me?
Hi,
All right.
Miguel.
Hi, Aaron.
How are you?
All right. Aaron is your go-to guy to ask the questions, even if you're not a hardcore developer today. If you are just trying to follow the workshop and maybe you're not as technically efficient, you want clarification, you want anything, Aaron is your guy. He's the one that can translate hard complexities, what we're trying to do, into easier to understand human language. So please take the advantage of Aaron today in the most positive way and ask him questions in Discord. And I'm sure that he will follow up. So I'll give the stage to Aaron, and right after the workshop, I'll jump in and make sure that we answer any of your questions as well that you had together. All right, Aaron, take it over.
Thank you for the introduction. So yeah, I would also like to welcome you to this first episode in the workshop series. This will be Intro to Swarm. And I think this is very much needed, because Swarm can be or may look like an extremely complex system. But I do believe that if we peel away some of the outer layers, then we can find the foundational ideas behind Swarm, which are quite simple and elegant, and they are enough to run and serve a decentralized storage system. So, my main goal today is to demystify this whole thing about decentralized storage systems and Swarm, of course. And how we are going to do that. So, on the agenda, the first 5 points are going to be some animated visuals. So I prepared these to try to demonstrate the basic concepts which are needed to run a decentralized network. So namely, that will be comparing the topology of systems like the traditional client-server model with the peer-to-peer network. Then we will introduce the first swarm concept that's going to be chunks. And after that, we define two protocol rules. So the first one will be who stores the chunks in this system. And the second one will be how we locate those chunks. And I argue that defining these two rules is sufficient to have a decentralized storage system. But of course, there are many other layers, and one of them is the economic system that Swarm has. So I will be also introducing that. But after that point, I will have to make some amendments because I will be simplifying things, oversimplifying at some times. So I will have to mention some other subsystems or features which I ignored in these first five points. And at the end, just to unwind, we will look at 18 use cases of Swarm. So some of these will be use cases which already exist today. Some will be ideas for developers. Some will be serious and others will be silly and fun. So let's jump into it. So the first animation that I created is about network topologies. So here on the top, we see the traditional client-server model, and below that is the peer-to-peer decentralized model. So in both of these cases, you as a user want to access or use some service. So in the traditional model, we see that service is served to you by a server. This server and this service very likely belongs to some private company. In the peer-to-peer system, this network of nodes is run by ordinary people like you and they together provide a service. And we will be comparing these two models from five different angles. That will be permission, identity, data ownership, availability, and censorship. So let's start with permission. So in the traditional client-server model, to start using a service, you need to first accept a privacy policy, then a terms and conditions. Maybe you need to prove that you are over 18, but you might be getting geo-restricted because you are from some country which is discriminated by the service provider, even if you don't agree or even oppose those views of your country. Maybe you are blocked because you are using an ad blocker or some tracking protection, and there can be many other arbitrary rules like there can be only one account per IP address. So if your spouse or a roommate is using that service, then you need to write a heartfelt letter to moderators that pretty please, this is my situation. And then you are oversharing a lot of personal information that you shouldn't be in the first place. So in the peer-to-peer model, permission works a very different way. You install the software, this node, and from that point, you are participating in the network. You don't need anybody else's permission for that. So next, let's look at identity. So in the traditional client-server model, most probably first thing that you need to do is create an account. That will be an email address and a password. And from this point, you can only hope that, for example, the password that you provide will be hashed and they are not storing it in some plain text raw format. Then the best thing that you can do is hope that employees, not all employees, have access to the live database, so that if one employee becomes compromised or becomes an adversary, then they can impersonate you, they can leak the data, or they can leak the whole company's data. So it can be a can of worms uh, for failures. Next up, data ownership. In the traditional client server model, as you are using the service, oh, sorry, I missed identity in the peer to peer system. And it's quite essential. So in the peer to peer system, mathematics have solved this for us with the asymmetric cryptography. You generate a key pair, that's a private key and a public key. The public key is your identity, and with the private key, you can prove that you are you. You don't need to reveal any further personal information. With this key pair, you can encrypt messages for others. Others can encrypt messages for you, and only you will be able to decrypt and make sense of them. So now back to data ownership. So as you are using the client server, a service from the client server model, you will be generating data. That data will be stored on the servers of that private company. And for example, if you delete some of your data, what really happens is that piece of data gets marked as deleted. You cannot be sure if they actually remove that content. And they might use this data to for training purposes, uh, for sharing with advertisers or selling to others. A lot of third parties may come in the picture. Data ownership in a peer-to-peer system works again in a different way. So with the key pair that I mentioned, you are encrypting your data. And even if somebody else from the network, some node operator, is storing that data for you, even in that scenario, only you can make sense of that data. Unless, of course, if you intend that data to be public for everyone to see. But you make that choice. The fourth item here is availability. So in client server models, the server and the service might go down anytime due to human error or stopping the service, or maybe they just change the terms and conditions for that service. And recent events with AWS and Cloudflare displayed this problem perfectly, that Web2 is owned by the big players. It's in a very monopolistic situation. If AWS or Cloudflare goes down, then it takes down half the internet with them. So I'm not saying that in peer-to-peer systems there cannot be failures, but there is no central party that can leave and then the system collapses. So if some nodes disappear, then other people can start running new nodes, or existing people can scale up with multiple nodes. And even in a bad situation, like for example, if the developer team disappears from the project, these peer-to-peer projects are usually and should be open source, so others can fork the project, take over, and continue improving the protocol. Lastly, censorship. So in the traditional client server model, maybe you are breaking the community guidelines, maybe not. Maybe it's a human evaluating it. Maybe it's an algorithm which doesn't understand sarcasm, but you might get shadow banned, you might get demonetized, you might get removed from the system at their discretion. And I want to bring up algo speak here. So in social media, a lot of the posts are saying unalived instead of killed, just to avoid being demonetized. And it's just really stupid that private companies are making us self-censor the way we speak just because of the arbitrary rules of the platforms. And in a peer-to-peer system, there are also rules there that's called the protocol, but protocols are mostly technical. But I also don't wish for a Wild West in peer-to-peer systems. I think my key point here is that instead of having others decide for us what's harmful, what should be removed, what should be censored, empower people to make this decision for themselves with free software, with open source tools. So if I want, I can have access to everything. If I want to narrow it down, then I may do so, but make it my decision. And obviously, you can tell that I'm biased towards peer-to-peer systems, but I also have to acknowledge the fact that Web3 is full of scams. It has god awful UX. And if you lose your keys, then you lost access to your identity and data. So there is still a lot of engineering work that needs to be done to make this widely usable. And with that, let's move on to chunking. And this is where we bring Swarm more into the picture. So obviously, Swarm is decentralized storage. Here we have an example file, an image file, that's exactly 12 kilobytes for demonstration purposes. And a chunk is a canonical unit of storage in Swarm, which is 4 kilobytes. So chunk, 4 kilobytes of data, canonical unit of Swarm. And a very important property that it has is that it has an address. This is 32 bytes, so 64 hexadecimal characters. And since these are always 4 kilobytes, if we want to take a file which is 12 kilobytes, we will split that to 3 chunks. In this case, these 3 chunks. On the network, they will be addressed by these hashes, also called as references. Okay, so now we have prepared this file to be put on the Swarm network. We have these 3 pieces of chunk. So how do we address our whole file? We see that just with these 3 chunks, that's not possible. But Swarm has this concept of a root chunk. So a root chunk only contains pointers to addresses of other chunks. Since each chunk is only 32 kilobytes, then this root chunk will contain 96 bytes of data, pointers to the 3 chunks. This chunk also has an address, and if we want to address our data in full, we will refer to it by the root chunk. So now that we know what a chunk is in the Swarm system, let's talk about storage rules. Which node holds which chunks? So here on the right, there are 4 nodes. An important property of nodes is that they also have an address. This is generated the first time that they run, and the key pair is generated, and then their address is derived from that. And the rule in Swarm for storing is that these nodes split up the address space to even slices, so equally sized segments, and each node stores chunks for that range where they fall into. So in this case, we are splitting the address space. So from all zeros to all Fs, we are splitting it to 4 evenly sized segments. And in each of these segments, there is a node. And once a chunk comes and is intended to be stored in the network, for example, this one starts with D7, this will fall in the last bucket based on the node address and the chunk address. So this is the basic rule for storing chunks. Now that we know how and where chunks are stored, let's talk about retrieving, locating, and retrieving these chunks. So here is a small example network. This is us at the bottom. This is our node here in the middle, and our node is connected to 4 other nodes. So let's put a chunk in the network. This is chunk F6. This is stored by node FD since they are close to each other. And this is me sending a request to my node, please fetch me chunk F6. So the request goes to my node. And the rule here is that my node first checks if it is holding this chunk. So we can see that obviously it is not holding the chunk. So the next thing it does is that it looks all 4 of its connections and selects the peer which is closest to the chunk that we want to seek. So we see that 3D 28 are smaller than F6, and our current node, we have 7D and 9.5. And out of these two, we select 9.5 since it falls closer to the F6 address. So we forward the request to this node, and this node does the same exercise. It first checks whether it is holding the chunk. It is not, so it looks at the connections that it has, that 7D, B9, and FD. So it forwards to FD because that's the node closest to the chunk. And finally, we arrive to the node which is actually holding the chunk. So that node starts serving this request and backwards the actual data to the originators. So the data gets back to us. And this is true for all chunk retrievals. We place a chunk in the network, we forward it to nodes which are closer than us. Those nodes repeat the same until we arrive at a node which is holding the chunk. And after that, we backward the request and we get served the data. By knowing the storage rules and by knowing how you can locate chunks on the network, I would argue that by using a library for the underlay network, for example, libp2p, by implementing these two protocol rules and having chunking in place, you have a MVP, some minimally functioning peer-to-peer storage network. But as the next step, it's important to make a comparison between two types of networks. So the first one is an altruistic network. Altruistic networks are free to use, but your participation is required. So for example, if we are talking about an altruistic storage network, if you wanted to keep your data alive on the network, you would have to keep participating, running your node to seed that data or to pin that data. Otherwise, if you leave, it might get lost. The other type of network is the incentivized network. So incentivized networks are usually paid. Swarm is also an incentivized network. Participation in incentivized networks are not mandatory because you are paying others to store data for you. So this makes this upload and disappear use case available by jumping on the network, paying for storage, uploading content, shutting down your node, and then maybe coming back a year later, and your data will still be on the network because you paid others to host it for you. So let's take a look at this visualization. On the right, we have 3 nodes running the network. We have the blockchain in the middle. The blockchain will help us coordinate the incentivization system. And here on the left, that's us. And we have a node which has a wallet. So it's currently empty. So we top it up with 100 BZZ from some other chain. Maybe we swap some other token, and we buy storage with that. We spent 56 BZZ from our wallet. That BZZ is now logged up on the blockchain, and in exchange, we receive a prepaid storage. This storage has 3 properties. So the first property is its duration. So in this case, we have purchased storage for 14 days. The other property is the capacity. Its current capacity is 4 gigabytes. And the third property is whether this is overwritable or not. So once we fill up these 4 gigabytes of data, then can we overwrite it or not? And as time goes on, blockchain is rewarding a random node on the network for storing this data for us. So in Swarm's system, Swarm's economic system, there is a redistribution of the BZZ that is paid by the end user so that they can store data on the network. That BZZ is redistributed to node operators to give them a monetary motivation to stay in the network and continue providing this service. Okay. So now is the part when I have to make my amendments. So the first one is that storing chunks only on a single node would be catastrophic. So what I mean by that, if nodes, of course, fluctuate, they can decide to leave the network despite the incentivization system. And if chunks were only stored on a single node, then that would mean data loss. So in the Swarm system, there are neighborhoods. There's a concept called neighborhoods, and neighborhood simply means a group of nodes which are close to each other in terms of their address, and they are redundantly storing chunks. So there is more than one node storing chunks for you. There is also a second type of redundancy in Swarm, which is erasure coding. So you, as a user, can make the decision to apply erasure coding to your data when you upload it. That will add a little overhead to your data. But even if whole neighborhoods disappear from the network and there is data loss, then erasure coded data makes it possible to repair or recover data, even if not every part of the original data is available. The second one is the bandwidth incentivization. So just before this, I was talking about how we incentivize storage. You pay BZZ so you can upload, and then that is rewarded to node operators who supply their hard drive. But storage is not the only resource that we use with the Swarm network. We also consume bandwidth by asking others to push chunks for us or retrieving chunks from them. So there is a second type of incentivization in Swarm, the bandwidth incentivization that is done on a peer-to-peer basis and also uses the BZZ token to settle these payments. And lastly, I mentioned that chunks, I'm going to come back here just for a while. So I mentioned that the canonical unit of storage is a chunk. Chunks have addresses, and these addresses depend on the content of the chunk. So these are content addressed chunks. That means these chunks are immutable and they cannot be tampered with. Uh, if I send a request for this reference and I get back the data, then my node rehashes the data that I just received, and it must arrive to this same hash. If it doesn't, then that means there is a malicious node who served me fake data. So this is what content address chunks can help with. But immutability with content address chunks can be cumbersome sometimes. So let's assume the use case that I'm hosting my web page on Swarm. I share its address with others. I register it with DNS. But then the next day, I make some changes to my website and then re upload it on Swarm. So by this logic, I get a new address, and the previous address is not updated. It's still the old version. So I have to reshare my website with my friends and family, and I have to update my ENS again with the new address. And that's cumbersome. And this would happen with every single update that I do to a resource. So there is a second type of chunk in the Swarm network that's called the single owner chunk. And without going into the details, single owner chunks enable higher level concepts which can help us work with mutable data or version data. So we can have pointers that always point to the latest version of some content on Swarm. So in this case, we could update our ENS to use a feed, a Swarm feed, which is using a single owner chunk, and that ENS would always point to the latest version of our website. Okay. And now, lastly, I would like to list the 18 use cases that I promised. So again, some of these will be just for fun. They will be silly, but also many of them are serious. Many of them are available today. And if you have more ideas, then we would be glad to hear them. So to start off, first use case is storing ID documents on Swarm for 100 years. Let's think maybe your birth certificate. For this, you can buy storage, let's say only like 100 megabytes, because you are not going to store data with large capacity. You are instead making the duration very long. And based on some quick calculations, this 100 megabytes for 100 years would today cost about 50 USD. But you have that storage, you keep uploading your important ID documents, and you never in your life need to pay for that storage ever again. Then the second one is backing up your data, for example, albums and files on Swarm. So with backups, there is this 3-2-1 rule. You should have 3 copies of your data on 2 different types of storage, and 1 copy should be offsite. I can recommend Swarm for the offsite storage. You can play with the duration. You know how much capacity your data is consuming. And by putting them on Swarm, especially with erasure coding and, of course, encryption so that others cannot see it, you have your backup ready and solved with Swarm. The third one is sharing files securely with only a trusted few. Swarm has the ACT feature, access control, where you can select only a few other node addresses and identities who can see that content. So you can use this if there is some data, for example, only for your family, or maybe some health data that you only want some very few people to see. You can use ACT for that and have it on Swarm. I already hinted at this just previously. Hosting your personal website on Swarm, because Swarm supports rendering websites out of the box. So if some data looks like a website, has an index HTML, then it will display it in a browser. And also you can use ENS with the BZZ protocol set as the content hash. And then you will have .eth or .eth limo working for you, serving your websites for Web3 browsers or bridged to Web2 by some reverse proxies. Writing a decentralized blog on Swarm. We have tooling for that. It's called EtherJot. It's a small tool which at some point it's my tool. At some point it intended to be something like WordPress for Swarm. But of course that would mean a lot more work with that. So it's more like a proof of concept tool at this point, but you can use it to write Markdown, then generate a complete website out of that, and then put it on Swarm. Transferring temporary files with others. For example, you can create a postage batch, a storage for about just a few gigabytes. You can make it overwritable and then reuse that if you want to transfer a file to somebody else. So you don't have to look for some service which is free, but free and allows it for you. This use case came from a community member. It might be my favorite use case from this list. Redirecting yield from some borrowing protocols, redirecting that yield to a storage's balance. Because once you buy a storage on Swarm, for example, for 14 days, you can top it up for more time at any given point. And in fact, others can also do it for you. So if there is some content on Swarm that is public and you want to keep it online, you can top it up yourself, even if you are not the originator of that data. So the idea in this use case is that you use some lending protocol which generates yield for you. And with a smart contract, you redirect that yield to one of your existing storages on Swarm. And that way, you achieve permanent storage on Swarm. This is a simple one. You can operate nodes to profit from BZZ. You might need to work on your setup. You have two choices. One is doubling your nodes. So a node that you run stores more and more capacity for the network, or you can increase the amount of nodes that you run and scale it that way. Monetizing gated content with permissioned access. So by using the access control feature of Swarm, you upload something on Swarm that you want to monetize. Let's say you set up a smart contract where people can pay for this content. And once you detect that it's been paid, then your node adds those identities to its access list and updates the data. And then that gives them access. Storing blockchain state on Swarm. This was an original vision for Swarm, and this is still something that we want to pursue. This would help, of course, validators, node operators for blockchain projects where the state already takes terabytes of data from their hardware. Mirroring public goods such as Wikipedia and OpenStreetMap. So these data sets don't have a financial motivation. These are strictly for the purpose of access to information, even in regions where it's normally censored. Streaming and watching video content on Swarm. So at Solarpunk, there's been a massive advancement in this area. A lot of the live events have been streamed on Swarm already, and you can also, of course, watch video content on demand after these events ended, simply utilizing chunks under the hood. Hosting metadata, cryptographic proofs, small JSON files, NFT images. So this was one of the first business use cases that we have seen, that since these files are normally very small, they only take up very few swarm chunks. So the uh, price or cost of this use case is very low, but it decentralizes these mission critical informations, for example, for a DAO or other project. Storing dApp databases on Swarm. So if you start developing new software where the backend is the blockchain, uh, the database is some decentralized storage, then you can use Swarm for that. And the front end is, of course, your browser. Hosting dApp front ends on Swarm. So this is something that I would like to see more of, because a lot of Web3 projects are still using traditional Web2 hosting for their front ends. And I would like to see more of them using decentralized storage solutions. Building a decentralized social media, something that combines this single owner chunk and feed concept, so that every participant in this decentralized social media network has a feed, and they can utilize Swarm's others features for messaging. Obviously, the database or the storage for posts and files would be Swarm. This could be done in a very nice decentralized way. Storing AI agent memories and intermediate data. A lot of AI interactions, or in a lot of AI interactions, you are sharing data that should be private to you. But in this case, you are falling to the same trap that this ends up in a database of some private company. So if you are working in the decentralized AI space, I would love to see more solutions which put agent memories on Swarm, or if there is a uh, big workload going on and one agent outputs some big data for some other agent to pick up, they can use Swarm for this message passing layer. And lastly, a fun one, running a Swarm TV or Swarm radio. So for this, I imagine that you create a storage that can be overwritten. Let's say you create this 4 gigabytes that can be overwritten, and every day you upload a new video or a new movie using this storage. You can override the previous one from the earlier day, and this way you are broadcasting some show every day for your viewers, so you can achieve Swarm TV with that. Okay, and that's the end of the use case list. So with that, I would like to thank you for your attention. I put the links.itsform.org here as the entry point where you can find links to all of our um, to our website, to our communities, so you can get in contact with us. If you have any questions regarding this workshop, also feel free to jump on the Discord and ask it there. I will be there to monitor it. And stay tuned for the upcoming workshop episodes. Thank you.
Thanks, Aaron, for the workshop and for overviewing everything. I think it's quite clear. I managed to follow everything through by not being a developer and try out some of the things. For everyone watching right now live, Aaron will stick around a little bit longer in Discord channel in case you have any questions. Go ahead, you can scan this QR code and you'll be directly taken to the correct channel for any of the questions for according to this workshop. But we do indeed have few more coming up in the months. So we have at the beginning of April, 8th of April, we're going to host a workshop for how to decentralize your AI agent, specifically with Swarm, and how to give different permissions. Then a couple of weeks later, so in May, beginning of May 5th, we're going to have another workshop of how to decentralize any of the front end. Again, this is amazing tool for something that you already have a working project and want to decentralize truly. And then last but not least, mid-May, on May 12th, we're going to host my personal favorite, decentralized streaming. So it's about video, audio, and live content across peer-to-peer. And we really invite individual folks like streamers, entertainers who want to decentralize the way they're streaming right now on the centralized platforms, or people that are looking to build alternatives to the current monopoly-like companies. And for any of the folks that have questions outside of the realm of Swarm 101 or want to hear what's going on in our community, what updates do we have, what are we working on? Being a foundation, we have a lot of different moving parts, from communications to universities and our research departments, to very specific events and tokenomics. And a lot of those questions can be raised and answered to you during our community call. And our community call is tomorrow at 6 p.m. Central European Time. It's also hosted in our Discord channel, but we will make sure we post all of the information, of course, on Twitter as well. So, Aaron, thank you so much for joining us. And I know that people will be able to meet you as well in person. We will be at ETH Prague together as well. Next week, people can meet me at ETHCC in Cannes. Just feel free to reach out to again, through Discord, through Twitter. We really do try to monitor those quite frequently. And in case any of you want to meet up, we will be sharing some of the links for the events as well. We also have ambassador program coming up, where you're going to be able to learn and contribute more actively to our ecosystem. But overall, we really want to hear also feedback of any of our documentation or tech. Anything is not working or working, you can always please come into our Discord channel, Telegram channel, Twitter. Just make sure you communicate, and we do monitor those. We do want to improve, and we're building technology for you guys, not only for ourselves. Our goal is really to break out of the bubble and bring the cypherpunk values to the larger axis of the internet folks. So thanks, Aaron, for teaching us how we can start decentralizing our storage. I love your user cases as well. I hope you can share with us the slide and we can share to the folks as well on Twitter and elsewhere, because there's a lot of different ways that we can start being more decentralized today from our own tech stack, not even in the companies, but something that I will be doing is definitely storing my documents and family pictures as well. Something that I want to remain forever, but not on centralized servers. So Aaron, thank you so much. And we will be seeing in next workshops in May. And if not, I will see you next week at ETHCC in Cannes or our community call tomorrow at 6 p.m. Central European Time. Thank you so much, guys, and enjoy the rest of the day or evening wherever you are in the world.